Hey guys, welcome back to the channel. So last time we remember we did this problem, which comes under this rotation sublist. So now we are doing this in the string sublist. So this is supposed to be the typical example. So let's see how we are doing it, and it's a medium level problem. The problem is 443, named string compression. So we are given an array of characters, compress it using the following algorithm. Okay, begin with an empty string. So the problem statement goes like this: we are given an array of characters. It is cars. Compress it using the following algorithm. We have to compress the array of characters as described here. So begin with an empty string. Okay, for each group of consecutive repeating characters. 162 repeating characters. Okay, triple A, double B, double A, double B, and triple C. For them, if the group length is 1, append the character to the S, otherwise append the character followed by the group's length. So A2, B2 and C3. That's it. The compressed string S should not be returned separately, but instead be stored in the compressed string S should not be returned separately, but instead be stored in the input character. Oh, return 6 and the first 6 characters of the A2, B2 and C3. The composition should not be written separately, but instead be stored in the input character array. Hash. Note that the group lengths that are 10 or longer will be split into multiple characters in cats. Will be split into multiple 5 different dimension lengths. So A only once, B wait a minute. Here A2, B2, C3 return for the first 4 characters of the input string A 2, 3, 4, 5, 6, 7, 8, 9, 10. So A, B, 1, 2. Okay, and the number should be okay. If the number is only 1, then we don't need to do anything. So let's go for it, guys, and let's keep s equals to new array that shows the uh, algorithm. I mean the compressed message. Also, let's see the constants. The length will be 1 to 2000 characters, and the characters will be if in lowercase English, lowercase English, uppercase English. Oh, okay. So the characters will be either uppercase or lowercase or digit or a symbol. So what are we gonna do? We'll start with L equals to 0 and R will be sliding from here, and we are going to check if the previous value and current value are same or not, and we'll be sliding like this. If the both are different, then I think we don't need L. Either way we need, no problem guys, let's keep it like that. R minus L is greater than 1, let's append the value. Let's do one thing. So as we have learned before, this will change the pointer to this. Let's see. So we now let's see what happens. So B2 C2 A2. So if the last element, C, okay. So this makes our work easy. If it would have, I mean, this case has been passed, then we have to think about a different solution. But we don't need to anymore. Let's do one thing. Let's define a function here. Uh, let's keep it straight. Let's see if this works. I'm sure this will work. What is regular where it is not associated with the oh. 1. Three, 4, 5, 6, 7, 8, 9, 10. How did it become Z? So display power will be 3, 4, 5, 6, 7, 8. Um, 1, 0, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. Okay, let's check submitting it and discuss the intention later. So submitting it. Now almost completed a major chunk. Seems like we have missed 13 cases. Let's see where it is going back. Triple A, double B, double A. Information plus 1. Sorry, sorry, sorry. plus 1 here. Okay, let's submit it again. Guys, it is working fine, but it is not looking elegant. Uh, and the space complexity seems like there is someone who is doing better. So let's check how others did the same problem. So, okay, if the length of characters is equal to 1, he is returning 1. I don't know why this is kept like this. We don't need to return anything. He could have written none, but he returned 1. So, just like us, he kept a pointer at the leftmost index, and he is traversing through the, I mean, through the range of length of characters. Repeating characters. I don't know why he is counting, but he is counting. So it is not necessary to count. He could have done right minus left, but he chose to do some other shit. Seems like our code is most elegant. I mean, more elegant than that. And if we maintain proper spacing, it looks cleaner too. Right. So if you guys, uh, I just forgot the word. Yeah, if you guys wonder why we didn't return anything, we are not returning anything, because we have to done, well, I mean, we have to do the operations in place. So, but we didn't do in place. We created a new array. Let's see if we created a new array. Wait a minute, guys. We didn't create a new array, guys. Instead, oh, he removed the. Well, it's not very different. He did the same thing as ours. Instead of creating a new one, he appended to the existing one. We could have done that too, but we didn't. So we created a new array. We were appending the order, I mean not order, the algorithm encrypted one, the encryption. And finally we are changing the pointer of curves to yes, which is the answer. And it is taking the car's address and verifying the array. That's it, guys. And our problem is also doing better, and the space complexity lies between 17.5 MB to 18.1 MB, which is very negligible, and the difference is also very low. If we submit it again, we might jump to a better place. So that's it, guys. I hope you guys understand and learn something new. Keep pushing hard, keep working, and thank you for listening to me. Bye, guys. We'll meet again with a new video.